Hello students, it's the online lesson again. So what we're going to talk about today is that we're going to talk about thermal energy. That's what you've learned in S1. But in S3, we're going to have a detailed discussion about it. Alright, so what we're going to talk about today is all about energy. So let's get started. So actually, I think that to most of you, you've learned thermal energy already. You've learned it already. However, this is the term for S1 only. Because in S3, we have a more precise word, more accurate word. So in physics, the term thermal energy is seldom used. Instead, we use internal energy. That's the word we usually use. So you can consider thermal energy as internal energy. That's the thing that we're going to talk about. So internal energy consists of two parts, namely Ke and Pe, which is kinetic energy and potential energy. So what are they? Actually? We're going to talk about it in this video. So in order for you to understand the Ke and Pe, kinetic energy and potential energy, first of all, we are going to take a look at this situation. Now assume that we have a -3 degrees Celsius of ice, and then it is being heated to 100 degrees Celsius of steam. So this is the process of it. First of all, -3 degrees Celsius of ice will change to zero. And after that, the ice will change to water. It melts, and will change to water, and eventually it becomes steam. So this is the whole process of it. I hope that you can understand it. This is what you can observe in daily life. However, when you take a look at it carefully, you find that some of them is talking about the change of temperature, and some of them is talking about the change of state. Now, change of state means from solid to liquid or liquid to gas. Solid, liquid, and gas are the states. So these are the states. Now, so therefore, because when you take a look at the change of it, you'll find that some of them is about temperature and some of them is state. So actually, we can talk about it in two types of energy. We'll call the change of temperature as Ke, which is kinetic energy, which is about the kinetic energy. And the change of state is related to Pe, which is potential energy. So therefore, now, internal energy, we can have two things. The first thing is about the kinetic energy, which is about the change of temperature. And the other one is about potential energy. That is related to the state. So now we can have the internal energy in a more detailed way, which consists of two things. Now, so as mentioned before, because there are change of temperature and change of state. So the change of temperature one, I'll use a red pen. The change of temperature one is called the change of kinetic energy. While the change of state, we call it the change of potential energy. So these are the main concepts you have to understand today. In microscopic view, the temperature of an object increases. So if the temperature increases, the particle move faster. So that's why we call it the hotter object has a higher kinetic energy. So this is what we call kinetic energy because the particles, the molecules move faster. So overall speaking, in microscopic views, that is in view of molecules. When the temperature is higher, then the Ke is higher also. So that's the thing. Meanwhile, for potential energy of particle changes when there is change of state. So that means it's from solid to liquid or liquid to gas. So these are what we call change of state. So when particles are further apart, the potential energy is higher. So you have to know that because in Form 1 you have learned different organization, different particle arrangement in solid, liquid, and gas. So overall speaking, you should know that this change of state will lead to a change of potential energy. So among all the three situations, please be noted that gas has the highest potential energy, while solid has the lowest potential energy. So that is to say, solid is larger than liquid. Solid is smaller than liquid, and liquid is smaller than gas. I mean the potential energy. So that's it. So overall speaking, kinetic energy consists of we call it total KE. Total KE. It consists of two things. The first thing is average KE, and the other one is total number of molecule. So you have to know that the average KE depends on temperature, while the number of molecules depends on mass. That's it. So when the temperature of object is higher, the average K is also higher. For potential energy, it is similar as the KE1. So total PE consists of two things, average one and the total number of it. So average PE depends on states, which is like solid, liquid, or gas. And number of molecules depends on mass. That's the thing you have to know. So it should be noted that gas has the highest average potential energy, while solid has the lowest one. That's the thing. The reason why we need average, because there's so many number of molecules. So that's why we may need to find the average one. To tell something about it. Okay, so in summary, what we have learned today is that previously we've learned the word called thermal energy in Form 1. However, in Form 3, we no longer use this word. Instead, we'll call it internal energy. So internal energy consists of two things, which is total KE and total PE. And each of them consists of another two components, which is the average one and the number of molecules. Students should be aware that average KE depends on temperature and average PE depends on state. Meanwhile, number of molecule depends on mass. So as a Form 3 student, you should be aware that which one is affected with which factor. They're all together four factors. First, second, third, and fourth. And you'll find that actually the second one and the fourth one are the same. So in order for you to understand in a better way, I'm going to show you later on. I'll show you some questions about this topic. So the last point, the internal energy of an object can be increased by one, heating, which is like putting the fire there, and B, doing work. What does it mean by doing work? It's just like you use a hammer to strike something. So that's what we call doing work. Or you rub your hands. So that's another thing we call it doing work. So in order for you to understand the question, the topics in a better way, you may now stop the question and stop the video and start taking a look at the question. If you can do it by yourself, that's good. And you may check the answer here. You can check the answer here. All right. So I'll talk about the first one. First one is about matching. You have to match the following terms in the description. The answer is like that. Measure of degree of hotness is about temperature. So total number of potential and kinetic energy is called internal energy. And the last one, heat transfer, is called heat. Now that one we'll talk it in later. We'll mention it later. So the most important thing you know 1 and 2. So question 2, if they have the same temperature, they must have same amount of, the first one is true because average K, when you take a look at the chart before, this one, the chart, you find that average KE depends on temperature. So it's true. Heat is the question mark. We haven't talked about it. Total KE, it seems that it is true. However, the answer is false because it depends on both temperature and mass. When you take a look at the table, total KE depends on two things. All right. And the last one, internal energy, because of course it's false because it depends on temperature, mass, and also state. Now, because these two are unknown, so we can't say it's true. We choose it false. Now here comes the question 3. The hot pot and the cup. Now you find the hot pot, the pot and the cup. This is the pot and this is the cup. Now you for sure that you know that the pot, the mass is much greater. The mass is larger here, while the cup is smaller. So they have the same temperature. Same temperature means same average KE. So briefly explain whether the following sentence is correct or not. So average KE is the same. For sure it's correct. Since they have the same, just write down temperature. Alright, so this is how we do it. Second one, total KE is the same. Now, we don't know, so actually you can take temperature is the same, okay. However, is the mass the same? It is not. So it is incorrect. Since the mass, sorry, it's not the mass. Since the pot has a greater mass, actually you should write down the pot of coffee has a greater mass. So the pot of coffee has a larger total KE. Now, because once again, let me repeat it once again, because total molecular KE depends on two things, which is average KE and also the mass. So because average KE is the same, however, mass is not the same, so you cannot say it's the same. That's it. Question 4, similarly. Two pots contain coffee of the same mass. However, one is at room temperature and the other one is 60 degrees. So the temperature is different. Now briefly explain whether the following sentence is correct. Average KE. Now for average KE, we should take a look at the temperature. So is the temperature the same? No. So the answer is incorrect. Since the temperature is not the same. That's it. Part B, total molecular KE. For sure, because this one is already not the same. This one is the same. So overall speaking, it is incorrect. Because the temperature is not the same. So you find that the answering technique is the same. So in order for you to know how to understand average KE or total KE, you have to ask yourself, what does it depend on? Now here comes the last one. Which of the following objects has the greatest amount of internal energy? Internal energy consists of so many things. It consists of total KE, and also it consists of total PE. And these two things consists of two things. The first one is about average KE and the number of molecules. And total PE is about the average PE and the number of molecules. So among that, you should know that average KE depends on temperature, while the number of molecules depends on mass. So let's take a look at it. First of all, 50 kg of melting ice and 0 degree and melt water, for sure that this one is greater, so cross out A. When comparing B and C, you should find that one is 0 degree, one is 20 degrees, so this one is higher. So no, not for B. I'll cross it out. So when comparing with C and D, both of them are 20. However, this one is 100 gram. So in this case, the answer should be D. So I hope that today we just talk about some energies. So I hope that every students may know how to analyze whether the total KE or average KE is the same or not. That is what you have to master in this online lesson. So if you're not sure how to do it, you can play back this video again, or you can come to me. After that, please go to Schoology and do some questions. So that will be the end of this online lesson. Goodbye.